All right, day two of this whole 100 days of system design thing. Today, I'm really taking it back to square one. We're going to look at the absolute bedrock of pretty much every app we use, and that's the client-server architecture.
So yeah, let's just jump right in. Have you ever stopped to think about this? I mean, every single app you open, whether it's for ordering food or scrolling through social media, whatever it is, it's having this invisible conversation with some powerful computer, a server, that could be literally anywhere in the world. Why? Why does it need that? Why can't the app just do everything by itself right there on your phone? Well, the answer to that is, it's pretty much the foundation of how the entire internet works.
And that fundamental answer is a pattern we call client-server architecture. You know, this isn't just another concept to learn. It really is the mental model you have to get right first. Before we even think about databases or caches or load balancers, none of that makes sense until you understand this. It's the ground floor that everything else is built on top of.
So what does this actually look like in practice? Well, in its most basic form, you've really only got two players in this game. On one side, you have the user's device, your web browser or a mobile app. That's what we call the client. And then on the other side, you've got the web server. It's that simple. The client asks for stuff, and the server gives it to them. That simple little dance, that back and forth, is basically the foundation for our entire digital world. It's wild when you think about it.
Okay, so we know they talk to each other, but how? How does that conversation actually work? Let's try to make this super concrete. Maybe use an example we all get. Let's think about a food delivery app.
So in that food app, your phone, that's the client. It's the part you're actually looking at, the part you're touching. It's showing you the restaurants, the menus, and it's what lets you hit that place order button. And that tap, that single tap, that's the request. Now the server, that's the powerhouse working behind the scenes. It's the one that gets your request, checks the menu, processes your payment, and actually tells the restaurant to make your food. It's the real brain of the whole operation.
And this whole interaction, it follows this really simple, kind of elegant pattern. We call it the request-response loop. You can just think of it like a four-step dance. Step 1, your phone, the client, sends a request. Hey, I want to order this pizza. Step 2, the server gets that request and does its thing. Step 3, the server sends back a response, like, yep, got it, order confirmed. And finally, step 4, your phone gets that response and shows you the result. That little confirmation screen. That's it. That's the loop, over and over again.
And yet, this visual really helps put it all together. You can see the user's device, the client, kicking things off with the request. It zips across the internet over to the web server. The server does its work, then sends the data, the web page content or whatever it is, right back. Then the user's device just displays it. And this exact cycle, this is happening billions of times, every single second all across the globe. It's pretty incredible.
So, okay, we have our two players, client and server. Now, a huge part of designing a good system is figuring out who does what. Where does the actual thinking happen? The business logic. This separation of concerns, this division of labor, it is absolutely critical to get right.
Well, the client's job is mostly about presentation. It's responsible for drawing the screen, for handling your taps and your clicks, and for keeping track of temporary stuff, like what you've typed into a form but haven't submitted yet. The goal is for the client to be thin. It asks for things, but it doesn't make the big decisions. The server, on the other hand, that's the authority. That's where the real business logic lives. It's what handles logins, it's what talks to the database, and it's what validates every single thing. The server is and must be the single source of truth.
And this leads to what is maybe one of the most important rules in all of system design. And that is, the client never talks directly to the database. Ever. And this is completely intentional. I like the restaurant analogy. As a customer, you talk to the waiter. The waiter then goes to the kitchen. You would never just walk into the kitchen yourself and start grabbing food, right? The server is that trusted waiter. It's the only one allowed in the kitchen, which is the database, to make sure everything is done securely and correctly.
Okay, so why are we so strict about this separation? What's the big deal? What are the big wins we get from designing systems this way? Well, it turns out this architecture solves some really fundamental problems that you always run into when you're building software. It really boils down to three huge wins. First up is central control. All your important business rules, they live in one place, the server. So if you need to change a price or update a policy, you just update it once on the server, and boom, every single client gets that change instantly. Second, and this is a big one, is security. You just can't trust the client's device. It could be anything. The server, though, that's an environment you control. It's trusted. So all the important validation has to happen there. And third, scalability. Think about it. If your app blows up and gets millions of users, you can't tell them all to go buy faster phones. But what you can do is add more servers on your end to handle all that new traffic.
And this brings us to a super common mistake people make. It can be really tempting to put a lot of the thinking on the client. I get it. It might feel a little faster at first, but trust me, it's a trap. It immediately breaks consistency, because now you have different clients running different versions of the rules. It completely breaks security, because you're trusting a device you don't control, and you totally lose that central control we just talked about. So a really good rule of thumb to live by is, if the logic actually matters, it belongs on the server, period.
Now, you might think this simple pattern is just for, small apps, but that's not the case at all. It's actually the fundamental building block that lets systems grow and scale to mind-boggling complexity. Just take a look at this diagram. I mean, this looks way more complicated, right? You've got all these other boxes, CDNs, a bunch of API servers. This could be the architecture for something massive, like YouTube or Netflix. But if you really look closely, the core pattern is still there. You still got a client, your phone, your laptop, your TV, making requests. And those requests are still being handled by servers. All that other stuff you see, all those extra pieces, they're just there to help the servers do their job better and faster. The fundamental relationship, that client-server dance, it hasn't changed one bit.
Okay, so let's do a quick recap. If we boil all this down, what are the most important things to walk away with? 1. Client-server is all about splitting up the work, splitting the responsibilities. 2. A really simple way to remember it is clients ask, servers decide. 3. This whole model is what enables central control, real security, and the ability to scale. And finally, number 4, this isn't just some abstract idea, it's the starting point, the foundation for almost every single modern system out there.
So, I'll leave you with this final thought. The next time you open up any app on your phone, just pause for a second and try to picture it. Can you now see that invisible conversation happening? Can you visualize your phone, the client, sending a request out across the world, hitting a server maybe thousands of miles away, and then getting a response back all in a fraction of a second? That right there, that's the client-server model at work. And that's our look at it for day 2.